Hey guys, so this is 6J. It's the last exercise as part of chapter 6. The questions that you're going to see in this part are more so your analysis type questions. So if you're one of those people that have a little bit of trouble with those analysis or worded or real life type questions, this is something where you should be paying a little bit more attention and maybe practice with these sort of questions. They can be a little bit hard though. And it's a little bit hard for me to teach it as well because a lot of the questions that they can be quite different, and it's hard to give me, it's hard for me to give you, sorry, an example that's kind of going to encompass or show you how to do all of them. So what I can do though is give you a few tips. So if you look at the top of the page here, I've written a few tips down that might help you out a little bit. I don't expect you to write these notes or anything like that, but hopefully the example that we do right now is going to help you out a little bit. When I do the example, I'm going to try to show you what is actually meant during the question by showing you actual models as well. But let's have a look at these these tips here. So what you do need to realize is that everything that you've learnt this chapter or through this topic, when we're doing our real world questions or our application questions, the maths that you're going to be using is the same as what you have been using so far. Okay, so don't try to think that it's going to be anything that you haven't been shown before. All the techniques are exactly the same. It's not going to be anything new. You just need to apply it a little bit. Another thing, and we're going to touch on this a little bit more in the specific question, but try to think about real world limitations. So a couple of common limitations that you might see might be in terms of measurement. So if we're talking about a length of something, we know that we can have like a positive length, but you can't have a negative length. Okay, so I'm going to touch on that a little bit later and you'll hopefully see what I mean. The same thing with other measurements. So for example, weight, you're not going to have negative weight, you're not going to have negative volume, etc., etc. Another thing that's really important, pretty much these last two tips here. So when you do these questions, you're going to have a few different letters in your problem. They all mean something. It's important that you keep track of what they actually mean. So in the question that we're about to do here, the letter X is representing a certain length of a box that we're making. So we need to kind of keep that in our mind rather than just thinking that X is some random number. It's not random. It does mean something. And the last dot point, visualize what's actually happening as part of the scenario. So with this question that we're about to do, I'm going to show you some models, as I said before. So it hopefully will help you out a little bit in terms of showing you what is actually meant in the question. But we're not going to be making little dioramas or anything when we do these questions. So it's important that we can visualize it and try and work out what the scenario is and how we could potentially solve the question as well. All right, so this example here, it's actually the same as one of the worst worked examples, and I think maybe one or two of the questions that you're going to have to do as well. So that's one of the reasons why I've chosen this one, so it can hopefully help you out a little bit more. So I'm just going to read through the question first, and then we'll get through. I'll go into each of the parts. Sorry. So we have a square sheet of paper, has edges of length 22 centimeters. Okay. Now 4 equal squares are cut out of the corners, and the sides are folded up to form an open rectangular box. Before I go any further, like we do have a diagram there, but before I go any further, I want to show you what I mean, like in real life. So we've got a 22 by 22 centimeter bit of paper. So it's this. It's just a bit of paper. This one is 22 by 22 centimeters. So that's what we're working with. And they've told us that we are going to cut out little rectangles in the corners there. Do you see how little rectangles are in the corner? And they're telling us that the length is X. So potentially, when we cut the corners out, we could have a bit of paper that looks like that. And they also told us that, sorry to move around a lot, once those corners are cut out, it's going to be folded up to make a box. So with this one that I just showed you then, I'm going to fold it to show you what I mean. Now I've got written down here our length of x is 3 centimeters. So I'm going to fold this up real quickly and show you what that box might look like. Sorry to keep you waiting, but I just got to fold this up. Alright, so I've folded that piece of paper up and you'll see that this is what the box might look like. Now it looks slightly dodgy, I can't kind of hold it nice and straight with just one hand. But that's what we might look like when our length, that's what our box might look like when our length of x is 3 centimeters. Now, we've used 3 as an example with that case, except x could be anything. So here's another bit of paper that I've prepared. This is when x is, I think 7 centimeters this one was. So you can probably visualize it, but I'm going to fold this one into the box, or the open box as well, and hopefully we can see the difference. So I'm quickly going to do that again. Sorry to keep you waiting again. So if our x is 7 centimeters, see how the box looks a little bit different? That one's kind of going in a little bit, but that's okay. Hopefully you can see what I mean. See how that's what our box might look like if our x is 7 centimeters, and this one here is what our box would look like if x is 3 centimeters. See how the volume might be a little bit different? So that's kind of what our problem's talking about here. So let's try to keep that kind of visual reference in our mind and base our question on what's going on there, because that's what they mean. I just wanted to show you to make sure you really knew what was going on. Alright, now let's have a look at the first question here. A, find the length of each edge of the box in terms of x. Now this is a box, so it's going to have a length, it's going to have a width as well, but it is a box. Once these are folded up, see how our height's going to be x centimeters. So I'm going to get the little box I made before. With this one here, that length of x there that I'm running my finger along, that was 7 centimeters. Okay, so if we fold it up, you see how the height is going to be 7 centimeters. All right, so let's just kind of separate each of them. So we need length, we need width, and we need height as well. Alright, now once it's folded up, what hopefully you realize is that we don't have that full 22 centimeters. If this x is folded up, and that x is folded up as well, we kind of miss those parts in our length, don't we? Okay, so instead of being that whole way across there, it's only going to be where my black line is. So it's only going to be that bit there. Now if that one's x, and that one's also x, which they are, I've tried to show that all these little cutouts are supposed to be x with these little dashes there. That means we're going to have 22 centimeters, but we're going to take off those two x's, aren't we? So the length is going to be 22 minus 2 times x, whatever length x is. We're not sure yet. Now width, this is a square, isn't it? So your width is going to be the same. We can look at this part. There's 22 centimeters. That's x. That's x. So once our box is folded up, this section here is going to be 22 minus 2x as well. And we went over just before how the height will be whatever your x value is, because it's folded up. So our height's going to be x. Cool. So we've done A. Now we're after the volume. Now remember, this is a box or rectangular prism. So we need to think about what the formula for volume is for that specific shape that we have here. So the volume of this shape would be our length times our width times our height, wouldn't it be? Now we have our length, we have our width, and we have our height. So we can easily find the formula for volume, can't we? Just by substituting in these little rules for length, width, and height. So let's do that. Alright, so now we have a rule that shows us the volume of this box depending on how long x is. Now this is a factorized cubic, isn't it? Can we see that we've got one linear factor, two linear factor, three linear factors? It hasn't told us to give our answer as an expanded version, so we can just leave it like that. I'm really quickly going to work out what the expanded version is. With any analysis type question, you're going to be able to use your CAS. So rather than doing this by hand, I'm going to save a little bit of brain power and a little bit of time as well, and I'm just going to use my CAS to do it. Now, attached to the end of this video, like I can't really film my screen, it's going to be a bit annoying. Attached to the end of this video, I might actually put like a screencast of what I'm doing on my CAS. So I'll go through the question again much faster that next time, and show you what I'm actually typing into the CAS to make my life a bit easier. So hold on just 1 second, or you might want to fast forward because I'm about to work out what it is without doing it myself. Alright, so once you've expanded it out, we should have this rule here. Alright, so we're done there. Now, we didn't have to give that answer there, but we've done it anyway. Okay, now we have that rule that tells us the volume of this box depending on whatever our value of x is. This next question, C, it's asked us to actually find that volume. So all we're doing is plugging in or substituting in our value for x, and it's going to tell us that volume. So if x is 1, what's the volume? Let's substitute it in. Alright, now that's something that you should be able to work out by hand, but again, we have our CAS here. If you want to save a little bit of brain power, make sure that you're getting it correct, go ahead and put it straight into the CAS. So I'm going to do that right now. Again, you might want to fast forward for a sec. And our volume should be 400. Except we can't just leave 400 as our answer. A volume of 400, what does that actually mean? We need to make sure we're giving units of measurement. Now everything was measured in centimeters, wasn't it? It even says it here. So everything's going to be 400 centimeters, except centimeters is just one dimensional. We're after volume, which is three dimensional. So it's going to have to be centimeters cubed. Okay. Now, we're doing the exact same thing, except this time we want to find the volume when your length of x is 10 centimeters. So instead of substituting in 1 as x, we're substituting in 10 as x. There we go. So again, go ahead, do it like as if you want to. I'm gonna do that. Should have put squared there. Make sure I don't make that mistake. And once you've put that into your calculator, or potentially done it by hand if you want to, you should get an answer of 40. Okay, so 40 centimeters cubed. Remember, don't forget that unit of measurement. So, if x is 1 centimeter, that's how large your box is, its volume. If x is 10 centimeters, that's how large your box is in terms of volume as well. All right, let's move on. So a few more questions here. Right, now find the values of x where the volume is 500 centimeters cubed. Now we're pretty much doing the reverse, sort of what we did in that last question. The last question we were asked to find the volume for a certain length of x. This time we're asked to find the length of x for a certain volume. So what we want to do, I'm going to write the rule back here so we can see. This time what we want to do is we want to put our 500 into volume and work out what x is. So let's put our 500 in there, leave the rest the same. Right, there's our rule. Now this might be a little bit hard to solve for x by hand. I think you can do it, but it might take a little bit of time. So we might use our CAS to help us out. So we want to solve for x, don't we? So let's use the solve function. Use your solve function. You type in your rule. We need to tell the calculator what we're trying to solve for though. Now x is what we want to know, isn't it? So we need to put x in here, close our bracket, and then it's going to give us a value for x where our volume is 500. So let me put that into the CAS and let's see. Okay, sorry that took a little while. I was just trying to sort something out. Your CAS should give you a few answers actually, so I'm going to put them to a couple of decimal places. But your CAS should give you x equals 1.34. Another answer will be 6.67. And another answer will be, just one second, 13.99. Okay, now let's not forget the units of measurements that we're using, so we're all centimeters. Alright, so it's given us these three answers. Now we're going to find something out a little bit later that this one might not really work for us. Okay, now I'm going to show you why that's the case a little bit later, but this one will not work. These two will be good. So there are two answers. All right, now it says here, find the maximum volume of the box and state. So once I've used my CAS to find that maximum, now I use the graph function so I could actually see it. We worked out that the maximum volume was 789 centimeters cubed, remember those units, when the length of x is, and it should tell you 3.67 centimeters. Okay, now the next one, it's asked to actually sketch that graph. So if you start zooming your graph out or in, or change your settings so you get a good view, you might see something like this. Remember, what you really need to do is copy what's on your screen. So this is volume in centimeters cubed, that's your y-axis, that one there, and this one is length of x, so a little bit in the corner of your box, and that's in centimeters as well. So once you copy down what's on your screen, it should look something like this. Alright, now I want to evaluate what's actually going on here. So remember, this is volume, this is positive, this is negative. Can you actually have negative volume? No, you can't. So there's no point in even drawing that part. So let's get rid of that. Leave the black line for a second. This here is the length of x, so it's a length. Can you have a negative length? No. So let's get rid of that bit as well. That doesn't make any sense. You see how you can get the numbers for it, but it doesn't actually make sense in real life. If it doesn't make sense in real life, don't draw it. So that's why I'm getting rid of that section there. Okay, so this is showing me that when the length of x is 0, the volume is 0. Now, we worked out where the maximum was before. So that was when x is 3.67. We have 789 as our volume. Now let's have a look at this little bit here. You'll see that on your calculator, it'll tell you that it hits at 11 and 0. Now, I want to sort of talk about why this part here, it doesn't actually work. So I'm not gonna rub it out just yet. I'm gonna get the little example again. So I have my piece of paper. Now I'm gonna choose a reasonably high length of x. So again, you might want to fast forward because I'm about to cut this. Okay, so I've just cut it with a length of x of, I think it was 10 centimeters, maybe even a little bit more than that. See how this is going to be like a real tall, skinny box? So I'm going to fold it up. Now this is really hard to handle, you probably can't even see it properly, but we're supposed to have like a real tall, skinny box here. Like hopefully you can see what's going on, but it is hard to show you. I'm going to open it back up again. How much further can I cut this so it's still a box? You see those lines that I've drawn? They were halfway through each of the sides. I can't cut past those lines because once I cut past those lines, we don't even have a piece of paper anymore. It's going to be gone. So I can't actually cut further than halfway of my piece of paper because then the piece of paper doesn't exist anymore. Now the piece of paper was 22 centimeters long. Are you seeing why that's 11? If I can't cut further than 11, it's not going to work anymore. So this doesn't exist either because there's no box for any length of x that's longer than 11 centimeters. Same thing for 0 centimeters. If I decide to make my length of x 0 centimeters, that means I'm not cutting anything, which is this. Is this a box? No, it's just a piece of paper. Okay, it's flat. It's not a box at all. Which brings us to our next question here. State the domain. So the domain is the length of, or the values for x, or the lengths of x that actually work, Okay, so we can't really have x as a length of 0, can we? Because as I showed you before, that means a flat piece of paper. But we can have it just higher than 0. Okay, so if I put 0 as our lower end, we couldn't actually include it. I wouldn't be able to do that. I'd have to make it so the length has to be something larger than 0. 0 is not going to work. Now, let's go back to our graph here, but also how I showed you with the real piece of paper. I can't make my length of x 11 centimeters or more because the box doesn't exist anymore. So it has to be smaller than 11. Okay, so if I put 11 here, I cannot include that. So it would be a round bracket. And that's it, we're done. So that took a decent amount of time, but I tried to, show you those diagrams, and you might be able to skip through a lot. I hope you did, otherwise you wasted your time a little bit. I am going to show you on the CAS as a screencast now. So hopefully that helps you out as well.